A stealth ship is a ship which employs stealth technology construction techniques in an effort to ensure that it is harder to detect by one or more of radar, visual, sonar, and infrared methods. These techniques borrow from stealth aircraft technology, although some aspects such as wake and acoustic signature reduction are unique to stealth ships' design. Though radar cross-section reduction is a fairly new concept, many other forms of masking a ship have existed for centuries or even millennia. Shaping. In designing a ship with reduced radar signature, the main concerns are radar beams originating near or slightly above the horizon coming from distant patrol aircraft. Other ships are sea-skimming anti-ship missiles with active radar seekers. Therefore, the shape of the ship avoids vertical surfaces which would perfectly reflect any such beams directly back to the emitter. Retroreflective right angles are eliminated to avoid causing the cat's eye effect. A stealthy ship shape can be achieved by constructing the hull and superstructure with a series of slightly protruding and retruding surfaces. Furthermore, round shapes on the ship are eliminated or covered up. Examples include smokestacks and gun turrets. Also, cavities that present a horizontal face are to be eliminated since they act like a trap and are very visible to radar. To get around these limitations, many ships use features such as panels that cover reflective surfaces or use alternate designs of hardware. Also, every effort must be made to have the smallest gaps on the ship as possible. Common hull shapes include tumble-home hull designs which slope inward from the waterline, and swathe hulls which allow for better stability when using a tumble-home hull. These RCS design principles were developed by several navies independently in the 1980s using work done on aircraft RCS reduction as the starting point. The currently developed U.S. Zumwalt-class destroyer, or DD, is the U.S. version of a stealth ship. Despite being 40% larger than an Arleigh-Burke-class destroyer, the radar signature is more akin to a fishing boat. According to a spokesman for Naval Sea Systems Command, sound levels are compared to the Los Angeles-class submarines. The tumble-home hull reduces radar return, and the composite material deckhouse also has a low radar return. Water sleeting along the sides, along with passive cool air induction in the MAC, reduces infrared signature. Overall, the destroyer's angular build makes it 50 times harder to spot on radar than an ordinary destroyer. VISB is designed to elude visual detection, radar detection, acoustic detection, and infrared detection. The hull material is a sandwich construction comprising a PVC core with a carbon fiber and vinyl laminate. Avoidance of right angles in the design results in a smaller radar signature, reducing the ship's detection range. Britain's Type 45 anti-air warfare destroyer has similarities to the VISB class, but is much more conventional, employing traditional steel instead of carbon fiber. Like VISB, its design reduces the use of right angles. Sea Shadow, which utilizes both tumble-home and swath features, was an early U.S. exploration of stealth ship technology. Signature reduction. Stealth technology represents more than just a low RCS. Noise reduction plays a huge role in naval stealth because sound travels much better in water than air. Some of the techniques used include muffled exhaust systems, modified propeller shapes, and pump jets. The shape of the hull can have a great effect on the reduction of the noise from a ship. Another major element is signal emission control. Modern warships emit lots of electromagnetic radiation in the form of radar, radio, and even bleed off from the ship's electrical systems. All of this can be used to track a ship, and thus modern stealth ships often have a mode that switches as much of the electronic emissions off. The downside, of course, is that the ship then has to rely on passive senses and can't easily send messages further than line of sight. Also of great importance importance is thermal emissions. A heat signature can make a ship stand out like a candle in a dark ocean, making it easier to spot, and because it is possible to see infrared emissions through features that would normally hide a ship, such as fog or a smokescreen. Many detection platforms like patrol aircraft, UAVs, and satellites often have the ability to see multiple bands in the infrared spectrum, including heat. This necessitates the control of these emissions. The most common way is to mix any hot gases emitted by the main source of heat, which is the engine's exhaust, with cold air to dilute the signature and make it harder to pick out the ship from the background warm. Another method vents the exhaust into the water, though this increases the ship's acoustic signature, for the hull water can be actively distributed across the hull of the ship, cooling the ship. Another less crucial but still relevant part of a stealth ship is visual camouflage. This area is probably the oldest form of stealth, with records going back almost as far as writing of ancient mariners using visual tricks to make the ships harder to spot. Though still relevant, this area has taken on lesser importance with the advent of long-range radar materials. Just like choices in shaping, the choice of materials affects the RCS of a ship. Composites such as fiberglass and carbon fiber are great blockers of radar and give smaller vessels an advantage in further RCS reductions. However, composites are fragile and often unsuited to larger ships or ships that expect to take fire. The new laminates can partially negate some of the weaknesses. This restricts larger ships to metals such as steel and aluminum alloys. To compensate, a ship may include a coating of a radar-absorbing material, though this can be quite expensive and may not stand up to the corrosive effects of salt water. Examples: fully stealth types: Type 45 destroyer, Formidable-class frigate, Hamina-class missile boat, Visakhapatnam-class destroyer, Lafayette-class frigate, littoral combat ship, Independence-class, Sea Shadow, Skjold-class patrol boat, Visby-class corvette, Zumwalt-class destroyer, Hubei-class missile boat, Milgems, Horizon-class frigate, the Indonesian X-3K 63 meters stealth fast missile patrol vessel has a trimaran design with long but small center hull and has been built from carbon composite materials. Ships with moderate RCS reduction: De Zeven Provinciën-class frigate, future Dutch Navy offshore patrol vessels, F-125-class frigate, Kolkata-class destroyer, littoral combat ship, Freedom-class, Saxon-class frigate, Type 052C destroyer, Type 052D destroyer, Type 054A frigate, Tatarstan Gepard-class frigate, Project 21630 Bayern, Project 20380 Sterigushi, FREMM multi-purpose frigate, Ambassador Mk3, reduced RCS types: Braunschweig-class corvette, Gerald R. Ford-class aircraft carrier, Arleigh Burke-class destroyer, San Antonio-class amphibious transport dock, Atago-class destroyer, Sejong the Great destroyer, Changmagongyi Sunshin destroyer, Gumdok Shuri-class patrol vessel, Neustrashimai-class frigate, Tulwar-class frigate, Rotterdam-class amphibious transport dock, Kadar-class new generation patrol vessels, Alvaro de Bazan-class frigate, Chevalier-class frigate, Sigma-class corvette, Nongo-class, Admiral Grigorovich-class frigate, Kamorta-class corvette, patrol vessel PZM. Planned ships: Type 055 destroyer, Project 17A-class frigate, Project 21956 destroyer, Gallery.